In this video, we're going to look at one further statistical test, and that test is going to be the ANOVA or ANOVA. Both pronunciations are pretty common. And the first note I'm going to say off the top is that ANOVA stands for Analysis of Variance, and that is a lovely thing to know. But in fact, I think it's a misnomer because most of the time, especially in engineering statistics, it has nothing to do with why you're using it. It's more about what is happening behind the scenes. What it does, which I think is more relevant, is that the ANOVA tests for the difference between means when you have two or more. So if you think back to what we've seen already, the t-test for two groups is typically what we would use to analyze whether there's a difference of means between two groups. ANOVA is the extension to 3, 4, or 5, but can also be backfilled to use with two means if you like. If you do a t-test or an ANOVA with two groups, you'll get the same p-value, the same results. So let's see when this might come up. So we're going to do our usual loading, and what we're going to look at as an example, motivating example to start, is Consumer Reports, which is a magazine that does a really great job of studying car maintenance schedules and car reliabilities. That's one of their claims to fame. And what we're going to look at is a case where one of the staff members from Consumer Reports is interested in buying some model of used Toyota, 3 years old, and is interested in knowing whether the maintenance cost is going to be different for different possible choices of Toyota models. Fortunately, the staff of Consumer Reports has available a large pool of data on the maintenance costs for different vehicles as reported by different readers. So what we're going to do is we're going to load in the data, and then we're going to do our usual thing about trying to figure out what's in it. So this is a relatively simple data set. We have models, which include a number of different model types, presumably, and annual maintenance costs here. And what we want to do, I think, right off the bat is figure out how many models there are in the list. We've got Camrys base and upgraded, Corollas base and upgraded, but let's just make sure that actually happens. So we're going to look at our models, and then we're going to use that value counts function. And it's going to tell us that, yes, we have Corolla base, Corolla upgraded, Camry base, and Camry upgraded. And there's 40 of each of those in the data set. Now, a couple other things we might want to do off the top is to simply look at at print statements here so we can see all the output. I was thinking a histogram of the maintenance cost in general. So let's try that first, and then we'll add our, if we don't have to do it with this, we can do it inside the pandas setup here, maintenance costs, and we can just do a histogram of that. And so we see that the costs can vary quite dramatically, but reasonably normal distribution, except for this little bulge at the lower end there where people have $0 spent. More interesting for the question we're trying to answer, though, is there a difference between models? Here we can go to that Seaborn cat plot command, and just remembering the syntax, we set what we want on the x-axis, and that would be our model, capital M. And then in the y-axis is going to be the maintenance costs. Cut and pasted this time to avoid typos. And again, we have to set up what the data is. Here we actually called it data, so perfect. So this is the default plot, which will be a scatter plot. In fact, I'm just going to comment out the histogram here for a moment so we can get straight to the graphics of the separate categories. And right off the bat, it seems like there's not a lot of difference. Though with data points, it can be a little deceptive, so what we'd usually do here is change the kind to be a box plot. That's more traditional. We have larger pools of data. And here we see there is a difference between the middle lines here. Remembering the middle lines are medians. So, okay, maybe there's a difference, maybe there's not. Could we use a t-test to assess whether all of these are the same? No, because the t-test only works at paired groups, and there's multiple test issues. There's some fun probability questions involved with why t-tests every single pair is not the appropriate way to test for whether these four means are different. We're going to pull out our big guns here instead and say we're going to use the analysis of variance to test for whether these four means are the same or not. And just a point regarding what to look for in these graphs, certainly you can see the means are different, absolutely. But what also plays a role is how wide these bars are and also the sample size. So these bars here are very wide. That says that within each group, within all the Camry upgraded models, there is a wide range of possible maintenance costs. And so it's not unreasonable to expect some difference in the means between all these four different groups which have similar deviations here. If these had been really tight, error bars for the box plots, then these means would be more likely to be significantly different. So it's the two things. How different are the means, medians here, but means graphically, and how wide are the error bars across all the groups? Those are the two things that factor into whether the means are significantly different or not. All right, so what do we actually use for the statistics on this? Well, it's going to be the SciPy function with statistics, and again, you can Google this to track down the one-way ANOVA analysis. The F here is an F test, so this doesn't look like ANOVA at all in the command name, but you can see in the documentation that it is doing an ANOVA test, analysis of variance. And here we have a lovely summary that 2 or more groups have the same population mean. So that's exactly what we want to compare to. Our 4 groups of Toyota models have the same cost mean. Now, what's the inputs? We literally just rhyme off all 4 of the data sets, and what we get back are the statistics, which would be an F value here. Again, we've been typically ignoring those because we haven't had time to go into the fun statistics theory, but we also have that common denominator of all these statistical tests, a p-value. So we're going to look at that. All right. So we're going to grab this function and we're going to do our F first. We'll call it the stat, and then the p-value equals. And then we have to give the data in next. There are various ways you can see online to make this a little more efficient, but we're going to do it in the sort of the most, I think, low-level intuitive way here. And that's just to grab the 4 data sets that come out of the different models. So we're going to call it data 1 equals the model where it is the Camry base. Space there, and we want just the annual maintenance costs as a subset. So I think we need one more data here. Yes. So what are we doing again? We're taking a subset of the data. So identify all the rows in the data set that have a Camry base model, and then we're going to look up those rows and just return the annual maintenance costs like so. Let's make sure that runs. Because we have an extra bracket. There we go. That made it happy. All right. And now we actually have another quotation issue, I think. There we go. It's also the order of the brackets. That's what we needed. Data model matches, close bracket, matches Camry base, and then we grab each of the rows for that. Apologies for that little typo. Oops. And then, of course, we're just going to do this multiple times. And you can get more inspired with the names if you like. Again, these are intermediate data values that we don't typically reuse, so you can name them whatever you like. So we have camera base, and then we had Corolla base and Corolla upgraded. Make sure all those work, no errors, perfect. Then we can do our statistics. So we include our data 1, data 2, and the lovely thing about this is we just rhyme off as long a list of matrices or NP arrays is what these are right here, NumPy arrays. And then we add our usual print statement afterwards. P-value equals, and let's go 0.2f and see what that looks like. So 2 decimals, floating point, or fixed decimal place, and we are printing the p-value itself. Okay, so p-value is that, which is, again, let's do a little follow-up here. Let's call this our results and discussion. The null hypothesis is that all car models have the same mean maintenance cost, annual maintenance cost. Right. The null hypothesis, the default, which is nothing exciting is happening. Okay. So then what do we do with that? In this case here, what we learned from the p-value, the p-value tells us that we would see an F statistic. I'm just going to say these results, or something more extreme. In this case, the difference between the means, 30% of the time, if the null hypothesis is true. Hypothesis were true. Okay. Again, think of the sales pitch. You know, I'm a Toyota used car dealer. I've got a bunch of cars I want to sell, and I'm telling you, maintenance cost is basically the same. All these beasts, they're all basically the same. Don't sweat it. You can't go wrong with any of these models. That's the sales pitch. Everything's the same. Then you do your data collection as the consumer report staff member, and you find this data here, and you do your analysis, and you come up with a p-value of 0.30. Then you find out, yeah, out of all the times, if you just had random data where these four groups, where these four classes of cars were assessed, you get the same kind of distribution 30% of the time. Okay, that's pretty likely, actually. So what this tells us is we can't reject the null hypothesis. We can't reject the null hypothesis with this. There's no evidence, not strong evidence. So we would have to treat all the car maintenance costs as the same. And so what that means is even though we see different means for the four groups, that isn't reliable enough or big enough, given the other variations at play, to treat them as actually different. That would be our conclusion. You might as well take any one of the four models because they're all going to have essentially the same maintenance costs given the data we've been provided. Okay, and if that's the case, you're basically done because there's nothing further to analyze. Now it's worth looking at another example where maybe some of the differences are significant, and then we can look at what we do after that.